value theorem, and actually there's a link on Schoology about where this was used in real life. That was in a court of law. Yeah, otherwise I can do it on Monday. What? No, that's differential equations. Yes. The mean value theorem says that if my average speed, okay, you guys, my average speed is 85 miles per hour, that means I had to be driving 85 miles per hour. It's just this. If you take a curve, Indiana, but now with technology changed, I don't think they do it so much anymore. But in the old days, we got a ticket, and it gave you your timestamp. So you could find your average speed. And this is the average rate of change, the slope of the secant line. So we know how to find the slope of that. F of B minus F of A all over B minus A. Okay? And somewhere in here between A and B, you have to be able to draw a line tangent to this, provided that I have a continuous function and it has to be differentiable on the interior. This is not typed correctly. So F is continuous on a closed interval and differentiable only on the interior. I don't care about the endpoints. And this has been on the exam. It's on the exam last year, actually. Okay, this is the average rate of change, or your average velocity. So if you average 50 miles per hour, someplace the instantaneous rate of change has to equal that. That means on your speedometer, you have to be reading 50. So if you go to Indiana and you average 80, and the speed limit's 65, when you check through that last gate, they can give you a ticket for speeding, because if you average 80, that means you had to be going 80. And they've used it in a court of law to actually either prove innocence or guilt in similar situations. So the mean value theorem is used. In its real use in math, the biggest use for this is, besides the AP exam, is proving the fundamental theorem of calculus. Now, if you want me to prove it this year, I didn't prove it to you last year, I can, but when we get there. Problem is, I'm just worried about our time. So if we keep on our schedule, we'll have a good amount of time to review. If we don't, we won't have time to review. So there it is. Okay, and geometrically, the slope of the secant equals the slope of the tangent. That's all. So let's do some problems. Oh, that's example 3. What happened to example 1? Oh, there it is. Okay, you guys, let's do this problem. I'm going to start with a graph, though. You guys, what does that look like? So where is it? It's shifted 1 unit to the left. Okay? We're going to do this problem, and then we're going to do 1. And I'm going to find the slope of that secant line, because it's f of b minus f of a over b minus a. That's old stuff. Equals the derivative at some c value. So what's f of 1 minus f of negative 1 over 1 minus negative 1? What's f of 1? Or g in this case. What's g of 1? 1 plus 1, 2. So that's 8 minus, what if I put in negative 1? It's 0. And I drew a nice graph, so you already knew that. Divided by what? 2. Okay? Now I got to find the derivative. So what's g prime of x? It is 4, but it's What is it using calculus? 3x plus 1 to the what? Second times the derivative of the inside function, which is 1. So that's what has to equal 4. So this is going to be, if you want me to use x or c, it doesn't matter. Now, I don't know if you know what to do with this. You could multiply that out and then use the quadratic formula, or you can make this a little easier. Let's isolate the squared factor. Okay, David? I'm going to divide by 3, and then we'll square root. So I get 4/3 equals c plus 1 squared. Be careful when you square root, because there are 2 answers. And I'm not even going to simplify that. I'm going to leave it the square root of 4/3, because it's good enough, which is equal to the absolute value of c plus 1. Be careful. Square roots are not negative. Okay, guys? Trevor, you need to pay attention because you don't know this term. So, c plus 1 is equal to positive square root of 4/3. You really should look for both. And I've not seen this on the exam, but I would think that they will give you a point for looking for both, even if one might not be an answer. And c plus 1 is equal to the negative square root of 4/3. So solving for c, it's square root of 4/3 minus 1, or negative square root of 4/3 minus 1. But remember, my interval went from negative 1 to 1. Right? How big is the square root of 4/3? Is that bigger than 1 or smaller than 1? It's a little bit bigger. And that's in this interval. So that's going to be pretty close to 0. Is this one in the interval? Because there could be more than 1. That's going to be less than negative 1, so we have to throw it out. There are times, though, in the exam where you have to consider all the possibilities. Okay? And that's it. There's my c value. And it's pretty close to 0, so my picture's actually pretty good. It's pretty close to 0. It's the tangent line. I didn't do a very good job with that. Rotate it a little bit. Guys, stop it. Okay? So it's right here. Well, that's pretty close to 0. Now, in the homework, you might have more than one place. That's all the mean value theorem says. You do have some geometry problems. What about that one? Whoops, I think I'm missing example 2. Oh, there it is. There we go. I'm happy. Okay. David, please put your feet down. What's going to be true here? Does the mean value theorem apply? It has to be continuous. This is a rational function. It's discontinuous where? At x equals 3. It's 3 inside my interval. Yes. So you say mean value theorem does not apply. Not continuous. F is not continuous. Apply. NA. F is not continuous on the interval. And that occurred last year. They asked, I can't remember what they asked, but it had to do with the mean value theorem, and it didn't apply because there was a sharp corner there. So what about example 3? Well, is it continuous? Now, I know what the cube root looks like. Do you guys know what it looks like? It looks like this. There's a problem there. Where's the problem? You have a vertical tangent there, undefined. But let's prove it algebraically. So we have to do f of x is equal to x to the 1/3. So f prime of x is equal to what? No, it's not because it's odd. It's because the derivative is a vertical tangent. You can have other odd functions where that derivative is. Pardon? You can have other odd functions. X cubed is odd, but it doesn't have an undefined derivative. Okay? Now, I don't like the way that looks, so I'm going to rewrite it with positive exponents. It's the cube root of x squared. That does not exist at x equals what? So there's the algebraic proof. If they said there was a vertical tangent there, you would say the mean value theorem does not apply because that's a vertical tangent and f prime does not exist. It depends on what they give you. I've seen them give you stuff as obvious as that. Okay, I think we have one more. What about this one? Does the mean value theorem apply? It's not differentiable at 0. But do I care what happens at the endpoints? Do you remember? I don't care at the endpoints. So yes, it does apply. So you're going to do f of 1 minus f of 0 over 1 minus 0. That's equal to the derivative. Well, guess what? I did the derivative. That's right up here. So it's 1 over 3, the cube root of x squared. Now you may not, I don't know if you know how to do the algebra. What's f of 1? That's 1. 1 minus 0 over 1 minus 0, so 1 equals this. I need to solve for x. How am I going to do that? Well, it's a proportion. Why don't I just cross multiply? So it's 3 cube root of x squared is equal to 1. And then you have to isolate that radical. So we'll divide by 3. So it's the cube root of x squared is equal to 1/3. How do I get rid of the cube root? Some of you will see how to do this. Pardon? You can. But wait a minute. Yeah, it's 2/3. It was 2/3. I'm going to do it one step at a time. Let's get rid of that. You're right. I'm not saying you're wrong. You're right. Some of you will see it faster, but not everybody will. So this is x squared equals 1 over 3 cubed is what? 27, right? And then now what do you do? Square root. Be careful, there are two answers. Are they both in the interval? I don't know. I don't remember the interval. And if you had gone negative 1 to 1, like this, there are two values, this one and this one. Sorry, my picture's not great, but so we have to throw out the negative 1 because it's not in the interval. Oh, okay. And that, oh wait, there's a little bit more I think in this section. I would say that was it, but that's not it. Do you remember this? Do you remember that if the derivative is positive, the function is increasing? And I don't memorize it. This is increasing. This is also increasing. And the first derivative is positive. I hope you know this. Quick review. If it's decreasing, what's true about the first derivative? Not concavity, but it's negative. Now, do you remember, okay guys, do you remember concavity here? How do you know? Concave up, and you're feeling up, F double prime, is positive. If you're concave down, like a frown, F double prime is negative. And to prove, guys, you can't say it as a function as an inflection point because the concavity changes. You have to say it as an inflection point because the second derivative changes sign. And we did all that. Now, where are the candidates for inflection points? Don't forget the undefined ones. Now I think that's it. Oh, no, we still have the first derivative test. It's not time to go. Remember the first derivative test? To review it, so we're done, you have a first derivative test. I do a little line graph. Now, Eric, you need to listen to this because guess what? This little line graph doesn't count in your explanation. So if I'm looking at a function that's obviously a max, what's going to happen to the first derivative? Positive, negative. I just draw the picture. What if it's a local minimum? That's negative, that's positive. Sometimes there's no sign change. If there's no sign change, you don't have an extreme value. Okay? Now, do you remember the second derivative test? We reviewed that in the Taylor polynomials. First, you find the critical points. So you have to do a first derivative. First derivative. Then you find the second derivative and evaluate that at the critical points. Because what that tells you is if that is a max or min, you will get a concavity. So if you do f double prime of c is positive, and I worked this out because I haven't memorized, then that means my function would look like this. It's concave up, right? And therefore it's a minimum. If f double prime of c is negative, that means it's concave down, and that's a what? It's a max, right? And we could do that. We could find that. I'll let you guys do that tomorrow if you want. Unless you want me to do it today. Okay. Well, we can just get this done, then tomorrow's totally work time. Okay. Eric's going to help me. And Ori, put the phone away. What's the first derivative? I got to find integrals where f. Okay, you guys, here's what I do when I do these problems. I justify my answer first. So I'm looking for f prime. This is increasing. F prime negative is decreasing. Then I can do that fairly easily. Concavity, guess what I'm going to need? F double prime, changing sign. Because if I figure out how to justify it, then I know what to do. Okay, so what's f prime? This is an easy one, right? 4x cubed minus 12x squared. It's hard to find good functions with a second derivative will be nice. Oh, right, it's 12x. Now, how do I find where it's increasing? I look for where it's 0 or undefined. So I will factor out a 4x, and I'm left with x squared minus 3. So I've got zeros at x equals 0, positive square root of 3, negative square root of 3. Now, do you know how to do this little sign chart the easy way? Without testing intervals? Well, it's a cubic, so I know it does something like this. It has to be that shape. So it has to be up here, so it has to do this. It has to. So this is negative, this is positive, this is negative, and that's positive. Since this is 0, I know my function's going to be nice and smooth. So it's decreasing from negative infinity to negative square root of 3. Don't worry about open, close. It doesn't matter. And from 0 to square root of 3. I can do that. And it's increasing, but we don't count it wrong if you don't do that. From square root of 3 to 0 and square root of 3 to infinity. But that's only, okay, you guys realize you get two scores. Okay, the A-B score, those problems are all sorted, and you get a score. So this is not going to help you on the BC part of the test. Okay? And one of the free response, the double bubble, you get 4 points towards BC and 5 towards AB. Usually it's a differential equation, the 5 points. Then the other 4 points might be something to do with L'Hopital's rule. Well, that's in this chapter, and it's not going to be easy. Okay. Oh, do I have any max or mins? What is this one? Minus the positive, it's a minimum. And you say that because the derivative goes minus the positive. What about this one? Max. And this is a min. So you know what it looks, you kind of know what it looks like. Well, kind of. Okay, notice what it says. 2 days in this section. That is Friday and Monday. What's the second derivative? So if you factor out a 12, x squared minus 1. Well, it's going to look like this. Are those inflection points? Yes, because the sign changes. I don't think it's time yet. Hang on. No, it's not. You got a couple minutes.